Good morning. So I am E. Ilavenil and today we are going to see about rigid body statics. So the rigid body statics starts with the study of moment. So we can remember the engineering idealization that we consider a body to be a rigid body only at the presence of moment, or we can say with the non-concurrency of forces, which is going to make it as a moment. So with this, moment gains a lot of importance in the study of rigid body dynamics or rigid body statics. So the moment is an effect that tends to rotate a body in its direction. So similar to what we studied in statics, it is the tendency of the moment similar to the tendency of the force, and here the rotation may not happen in statics. So in dynamics, because of a moment, rotation would happen, but in statics, we try to rotate with a moment, but the rotation doesn't happen because of certain equilibrium conditions. So a moment can be produced due to a force or due to a couple. A moment can be produced due to a system of forces also, that is a number of forces and moments together. Moment of a force. So moment is a vector quantity given by m vector and is described about a point or an axis. So although it is a vector quantity, we can study that as a scalar quantity, and the scalar value of the moment due to a force is given by the product of the force and the perpendicular distance from the point or axis about which the moment is described. So with an equation we say m, of course this is a scalar m is equal to f into d perpendicular. All these are scalars. M is equal to f into d perpendicular, which is equal to fd sine theta. So here the theta is the angle between that force and the position described from the axis. That is the distance between the axis and the point of application of force. So the SI unit of moment is Newton meters. Moment vector. Vectorially, moment of a force is given by the cross product of position vector of the force about the point or the axis of the force vector. To be noted here is the commutative nature of the vector cross product. That is, here the moment vector m vector is equal to r vector cross f vector, which cannot be written as f vector cross r vector. So vector product is non-commutative and we have to use it in the same order given here. So m vector is equal to r vector cross f vector, which is also equal to rf sine theta into a cap, where a cap is the direction perpendicular to both r vector and f vector, which can be said as the direction perpendicular to the plane containing both the position vector and the force vector. So moment vector is represented with direction in a single expression as m vector is equal to mx into I vector plus my into j vector plus mz into k vector. So with respect to an axis or a point, Moment can be viewed as clockwise or anti-clockwise or counterclockwise, as we say. So counterclockwise moment is normally considered positive and the clockwise moment is taken as negative. This is a sign convention followed conveniently and mostly throughout the world, but this may not be the single way to see it. It is as per our convenience. We can change the sign convention also, but it is better to use the universal international sign convention. So Varignon's theorem. So this is a very useful theorem for finding moment when it is difficult to find at certain circumstances. So Varignon's theorem states that moment at any point of force acting on a body is equal to the moment of the resultant at that particular point. Sorry, not the resultant, it is the components at that particular point. So we can also infer the following corollary. So if many concurrent forces are acting on a body, then the algebraic sum of the moment of all the forces about a point in a plane of forces is equal to the moment of their resultant about the same point. So either we obtain the moment from components for the single force, or we can go for a number of forces for which the moment is applied by having the resultant and taking the moment of that resultant. So Varignon's theorem can be represented as r vector cross f vector is equal to, or say r vector cross the resultant is equal to r vector cross f1 vector plus r vector cross f2 vector plus r vector cross f3 vector and so on, where the resultant f vector is equal to f1 vector plus f2 vector and so on till any number of forces. So sometimes when we work in scalar, the multiplication of scalar components and adding is easy. So for a single force also we use Varignon's theorem, obtain two components and add the moments separately, and we go for finding the final answer. When working with vectors, adding of so many vectors is easy, but cross product of so many vectors might not be so difficult, but still it is a bit tedious in work, and adding several vectors and finally going for a single expression of cross product is going to be the more convenient form of work. So Varignon's theorem helps in both the approaches for finding the moment. Moment due to coupled. So two equal and opposite forces separated by a distance constitutes a couple. So it is actually a couple of forces which we shortly call it a couple. In a couple, the linear effect of the equal and opposite forces cancel each other, whereas the pure rotational effect is provided because of the distance between the two forces. So the couple is given by force into distance Fd, which is not to be taken 2Fd because two such forces are available. So here d is the perpendicular distance between the forces. So here when two forces are available with a distance between them being d in the perpendicular direction, the total couple given by the two forces is Fd. So next we see what is a force system. A force system is essentially a system which is available on rigid bodies, for which we have to solve and study. So a number of forces and couples acting together on a system is called as a force system. Actually, on particles, a set of forces can be called as a force system, but here we have both forces and couples. So here when we say couples, we can include any moment. However, as we say, a couple is a pure rotational effect, whereas a moment means it includes couples and forces. So when we want to refer to a pure rotational effect, we call them as couples. So a force system consists of forces and couples. So this is similar to the concurrent force system having a single resultant. A non-concurrent force system or a rigid body system has a resultant as a combination of single force and a single couple at a point. So for a given point, there will be a force with a particular magnitude and direction and a couple with a particular magnitude and direction represented at a given point. So this can be transferred to any other point also where the couple value changes. So it can be brought to a particular point where the couple is cancelled out. So we have a single resultant available at a particular point which cannot be just like that moved to another point. This is something that we have already seen. A force is represented with a point of application. So it can be a resultant force at a particular point or a force and a couple at any point. So this is the force system. So we study statics with force system acting on rigid bodies. Thank you.